Simple network management.
Pwnd. Okay, start out with, my name is Deral Heiland. I'm a senior security consultant with Rapid7. And as Vic had mentioned, I've been doing this for a number of years. So this is my 6th time speaking, so thanks a lot for having me. I love coming here, this is great. And
my name is Matthew Kienow. I'm a senior software engineer. And when I'm not building and designing secure software solutions, I often enjoy researching and breaking them instead.
Woo!
So we'd like to change the way you think about simple network management protocol on embedded devices. We want to move beyond simple metrics and monitoring. We're going to explore a few major topics here. First, we're going to start and lay a foundational understanding of the simple network management protocol. And then we're going to explore a few specific devices that we researched that have information exposure vulnerabilities. And we're going to explore the process as well as automation. And then we're going to move into mitigation, risk mitigation, and open for questions.
So why? The big question is, why do we do this? Typically when I speak at these conferences, I always try to let people know why I'm actually doing any of this type of stuff. So this is kind of interesting. So as a security consultant pen tester, we often go into companies where we do assessments, pen testing, and we discover S&P enabled on a number of devices. So what do we typically do? We basically note it, and we write in a report, you know, this is a bad thing, you probably shouldn't do this. But we really don't go any further. Next slide. So let's add a new option to that. And that new option is, let's actually start taking a look at this stuff. So what is actually being exposed via S&P that is a critical issue to that customer? Can that be used by an attacker to do some evil, bad stuff? So that's how this whole thing got started. So I started looking at some of the stuff, and I continue to do that. So we have some, and that's how this talk got started. What's actually out there? It's bad. What do you mean it's bad? Let's explain it.
All right, so we have vendors that are creating new devices all the time, and they want to provide a means of managing these devices. And there are clients that are purchasing devices and adding them to networks. So we have networks growing in size and diversity of devices. Now, if there were independent management solutions provided by each vendor, that work would be very difficult, right? So we have a need to simplify that with a common management solution. So we take a look at network management. You have a network manager, and this is a software system that's responsible for monitoring and managing network elements. And a network element is any device that's capable of running a TCP/IP suite. Now, this could be anything from servers and workstations to routers, printers, and cable modems. Now, you have an agent is a software system that's running on that network element. And this software system is responsible for monitoring and tracking variables that are associated with various logical subsystems on that device and storing them in a local database. So there are a number of ways a manager and agent can communicate. In a simplified view, the manager can read or update values of variables on an agent, and an agent can report information back to the manager. So what does it look in protocol form? We standardize that communication, and we form a protocol. Now, the transport protocol is normally UDP. However, other transport protocols could be used. It was not strictly specified in the RFCs. The agent listens for requests on port 161, and the manager listens for requests on port 162. Taking a close look at version 1 provides a handful of messages. These can be divided based on the direction of the communication. Then the first 4 messages here are share the same format. A get request message is used to request the value of one or more variables. And a get next request is similar to a get request in that you're requesting value variable, except for you're requesting the value of the next variable. This is used for exploring table-based data. Not all data makes sense structured in a flat layout. For instance, if you're to look at network interfaces on a device, you have multiple attributes associated with each network interface. You would have a description, interface name, MTUs, IP addresses, etc. And then we have a set request, and this is used to update the value of one or more of those variables. In response to those three messages, an agent will send a get response message. This carries back the value of one or more variables to the manager. And then there's a trap, which is for event notification. This is outside of a request. If an agent needs to notify the manager of something that's happened on that network element, it'll send a trap message back. Taking a quick look at the structure of the message, the portion in the top right there, the top three in cyan, that represents the SNMP comment header. Note the community. This element is a clear text value that's used for authentication. It's kind of funny, isn't it? The value in the center is the get set header, and the values at the bottom in magenta, those are the variable bindings list. This is the list of the one or more variables. So you have an object identifier followed by the value of that. And the other message that I mentioned before was a trap. This is, again, shares a similar structure with the exception of the center value there. It represents the trap header. Looking quickly at major enhancements in version 2, they added two important messages. The first was a get bulk request. Whereas we would use get next request to retrieve the value of multiple variables, we can now use a get bulk request that sends a single packet and retrieves the value of multiple or a large set of values back in a single message. And then we have the inform request, and this is for acknowledging event notification. This is used for manager-to-manager communication that was added to SNMP 2, as well as providing a means of creating a trap with with delivery notification. So as before in version 1, when an agent would send a trap message, it had no way of knowing whether or not the manager actually received that message. With an inform request, the agent can now know whether or not the information that it sent to the manager was received, and if it wasn't, it could continue sending. Two new MIBs were defined. Again, there's some around manager-to-manager. And finally, some security enhancements. They developed a party-based system. However, due to the complexity, many favored the community version instead, 2C. This uses the same plain, clear text community as in version 1. And a little later, a user-based model was implemented in 2U. However, version 2C was the most widely adopted. Version 3 finally provided security enhancements. They created a security model that provided authentication, encryption, and integrity, as well as access control for the actual variables. And they added some changes that facilitate remote configuration and administration of entities. I'm going to turn it over to Deral, and he's going to introduce information management bases.
Thank you, Matthew. So Matthew's covered the SNMP protocol and the variations of that particular protocol. Here, I got it here. So I'm going to talk about MIBs. So what is a MIB? I mean, it's pretty straightforward. A MIB is management information base, but it's nothing more than a database. So that it stores information on the actual device or hardware device where which is referred to as the agent when we're talking about the protocols. And the manager can make requests to the particular MIB to extract the data. Pretty straightforward. Next slide. So a couple key things to remember we're going to talk about as we go through here is the OID, the object identifier. So the object identifier basically is how the MIB is actually laid out in structure, and that's how you make requests to it or identify key elements within it. The MIB OID is laid out in a tree design structure. So when the manager makes a request to the agent, he uses that OID to query specific key pieces of data out of this database, the MIB. Next slide. So the OIDs are referenced in two typical fashions. One of the fashions is a dot notation, as we see here, 1.3.6.1.2, whatever, all the way down to the key element you're trying to extract. Another method is with a human readable name, which I absolutely hate. You hate that? I can't remember that shit, man. That's like totally screwed up. So I like the numbers, which is much better. I'm a numbers guy, and I can remember a freaking ridiculous amount of numbers. So it's easier for me to remember the numbers and walk down through that. You can go to the next slide. So here is the tree structure. It's general. It's kind of like, okay, it's a tree that's fell down, but it's a tree structure. And we have, 1.3.6.1 is the key high element or high structure of this. And then you have all the other subcategories. The one I'm interested in, we're going to talk about today, is dealing with the private enterprise, which is at 1.3.6.1.4.1. Okay, you got that all memorized? It'll be a test at the end. Next slide. So we're talking about the private enterprise MIB location. And this is a number that is assigned to every vendor who wants to create his own custom MIB for his product. And that may be for a product. I've also seen it associated down to chipsets and stuff like that. So that's what we're interested in, 1.3.6.1.4.1, which is the private enterprise MIB. These numbers are actually assigned by the Internet Assigned Numbering Authority, IANA. It's easy to get one of these. I have one of these. I got it about a month ago. My number is 43555. Remember that number. That'll be important in your life. If you ever encounter that number, shut your damn system down and leave. Because I assure you, you will find no good by staying there. Next slide. So here is a couple numbers. And like I said, my number is 43555, and there's been a number of numbers at that. So there's quite a few of these. Everyone can get these. And here's some interesting ones I threw up here just because I wanted to fill up a slide. And some of the interesting ones are the ones down here toward the bottom. These are the ones you're going to encounter later in our presentations when we do some of our short demos. And they're dealing with some various products that we found issues in. So next slide. So when we're talking about the OID and we try to make reference to the database, there's two structures that we encounter within the management information base. One of them happens to be a variable value. So you make a request to the object OID, and then you request the variable value with a 0. It's a single instance of data that can be actually queried, and you can pull the information associated with that at that data point. Next slide. There's a more complex structure, and this is dealing with table indexing. So instead of having a single value, it's structured in an index structure. The purpose of that is, let's say that we're dealing with things within the device that fall in a standard category getter. So like a network interface card. So you may have, the MTU, the TTL, the IP address, and maybe some other key things. These would all be structured into a table index. And those are referenced, the same way in a structured format, but not with a 0. They're referenced and called via the table index. And this is a very simple structure representation of this. It can be very complex. It's just to let you know, a lot more complex than that. So next slide. So at this point, we've talked to you about the protocol. So we've got that out of the air. We talked about the management information base. So you should have an understanding of the manager, the agent, the general communication process that takes place. how the quarries may use OID to be able to pull data out of this database. Now we're going to show you how to steal shit. We like stealing shit. Stealing shit's always fun. So some high-level information. So as part of this research, you know, it's all about, hey, SNMP is exposed out there. And like Matthew talked about, the community strings. By default, devices have public and private as the standard community strings that by default are enabled on most SNMP installs. Well, our data, we went out there and looked, and we found that Shodan, there is over nearly, well, the number's over higher than this, 17+ million devices on the internet exposing SNMP that you can query and pull data out of. According to Shodan, so some of that may be devices that have aged out. They may not all be current. So let's say 50% of that's no good. So we're still looking at 8 to 9 million devices on the internet. So we're going to show you how to steal data from what, 2 million? I don't know. So let's go ahead, and I'm going to turn it over to Matthew, and he's going to talk to you about this specific device, and he's going to show you some of the data that we're able to extract out of this. And some interesting methods related to that.
Thank you, Daryl. We took a look at Aries, Motorola, and Netopia modems. Netopia was purchased by Motorola, and Motorola modems were actually recently purchased by Aries this year. During my research, I was able to acquire, actually, let's back up. Taking a look at Shodan results, we found almost 250,000 Netopia devices with SNMP exposed to the internet, and a little over 12,000 Motorola SPG models with SNMP exposed as well. During our research, I was able to acquire 2 Motorola modems for evaluation, and the SPG 6580 was found to expose information via public community string. And we're going to do a demo here. So there are various logical subsystems on these devices, and one such system is owned by the Broadcom Corporation, or at least their MIB table identifies that. I was unable to locate a MIB for this, so in part it's a lot of exploration of the data. You start by performing a walk of some given point, and you get a lot of data back. For example, we'll do an SNMP walk supplying version 2C with the public community string, and we'll point it to the IP address of this modem on our LAN here, and we'll start that crawl at the 136.1 that Daryl mentioned earlier. And as you can see, there's a lot of data that comes back. Sorting through pages of integers and hex values can be a little tedious. Sometimes these values pop out at you. It might be really obvious, and sometimes not so much. It involves a lot of interaction with the device, changing settings, and evaluating the difference between 2 executions. Joe will actually perform a demonstration of that shortly. But just to give you an example of what you can pull back, I'm interested in a single value now. So I'm going to use a SNMP get command, and this is going to use that get request message that I mentioned earlier. You can configure it for 2C with public community, pointing to the IP address of the device, and paste in the value that was interesting. And here we see the SSID of this device is returned to us. following the same process, we're able to find some more values under the same object. Right here, we have the WPA pre-share key. In clear text, nonetheless. That's also available via the public community string, which is enabled by default on this device. And the other interesting value here belongs to the Cable Labs Corporation. Now, I was actually able to acquire a MIB table for this, so I could learn a little bit more about what the values actually mean instead of reversing them from making configuration changes. But I'm interested in a larger block of values instead of one, so I'm going to use, let's use the SNMP bulk block command. Now, this is going to use the get bulk request message that I mentioned earlier. Again, configuring for version 2C with public community, point it to the device IP, and paste in this value. And it wraps a little funny because we made it big so you could see it, but what you see here, the first value in plain text is the username for the device. This is Cable Labs Portal Services. It's standard, and it provides the username for the device UI, followed by the password. And the third value there is interesting. It represents manufacturer local, at least that's what 1 stands for. This is meaning that it uses the manufacturer local device user interface. There are actually other options for custom images, remote URLs, as well as disabling the interface completely. Again, just to rehash the values that I pulled, and you can see a screenshot of the interface where those devices are actually with the actual values. Does anyone live in Raleigh? Do you happen to have a Nettopia device at home? We decided to run a showdown search, narrowing it down to a single ISP for Nettopia devices with SNMP exposed to the internet. And we found a little over 500 devices. Now, it's important to note that some ISPs are good about this. They're locking down SNMP on the internet side, but not all of them are, obviously. I'm going to turn it over to Deral to demonstrate the UB and Ambit devices.
To reemphasize what Matthew showed you is he initially gave you the slide where he said there was 250,000 devices out there. That is 250,000 devices that potentially, if the wireless is configured, they give up their pre-shared keys over the internet. And those 508 machines here in Raleigh potentially give up their passwords, their pre-shared keys, and also their web keys. If it's enabled for web, as if you need them, but that's another thing. So moving on to another series of devices, and this is the UBI Ambit devices. These particular devices, we found pretty much the same issues, okay? But these devices, go to the next slide. These devices, the Ambit, which is pretty much getting close to its complete end of life, is being removed off the internet. We still have about 12,000 devices. So if you happen to be in North Dakota, South Dakota, and you want to get free wireless, these devices give up their information also. They give up their pre-shared keys, their web keys, and their passwords. So most of these devices in the US are in North Dakota, South Dakota, and Wyoming area. Getting over to the UBI devices, UBI is a manufacturer of cable modem devices, and most of the devices are OEM devices. So getting your hands on the devices is difficult, at least the latest current devices. Most of their devices are used in foreign places, South America, Central America. But again, we're looking at nearly 250,000 devices that are exposing SNMP with the public community string enabled to the internet, according to Shodan. So next slide. So I want to go to demo here, but we're going to do something a little different. Since we've already showed you how to get the keys, we're going to show you how to do some quick comparisons when you're looking at data. I might shrink this down just a hair. So as an example, if we go ahead and, as Matthew showed you, some of the various commands that you can actually use. If we do SNMP, oh gosh, I'm like cross-eyed today. Public. And then we're going to go against the UBI device we have here is a DDW3611 device. And hopefully it's up and running. Okay, now this is the test. What was the community, or what was the OID that I gave you to point to the private MIB location? Bingo. 1.3.6. I think it was 1.4.1. Yeah, should be it. So we can easily dump this data. So if you want to look at the most important stuff, we found that typically, like we mentioned earlier, that's going to be located at the private enterprise location. So during analysis of a device, you never know what is available in the device. And if you're able to make modifications to the device, the coolest thing is take a snapshot of it, make a modification, take another snapshot. As Matthew had mentioned, a lot of times the data is quite obvious. When you're looking through there and you see, key things in there, you can go, hey, that's probably something important. If the name root is in there and then after that is a hash, hey, we may have a username and a password type thing. But a lot of times, it may not be quite as obvious, so you need to do some comparisons. So the purpose of this quick little demo is like, okay, let's go ahead and do a quick comparison and see how we can identify stuff. So in this case here, let's go ahead and capture this data out. So we're going to go ahead and just send this data over to a file called example1. So we can capture that out quickly, and then if we have access to the device, and here is a beautiful UBI device, and we can come over here and we can see that in this case the WPA pre-shared key is dead beef. We're going to go ahead and change that, and we're going to quickly save it out. And then we can go ahead and save that out. Hopefully I actually saved it. So we can send it to example 2. And then we can easily just do a diff. If we spell it, or did. But dids typically don't work. There you go. So we can compare these quickly, and as we can see, we have a number of things that have actually changed. It's common to see things like counters and stuff like that are constantly changing or incrementing. You're going to show those. But we can quickly find something, in this case here, which is the pre-shared key that has actually changed. So that's kind of cool. Don't do that to me, damn it. Shrink that down a little bit more so we can get this going. So Let's do another quick, just for the sake of doing something different. Since we've seen WPAs already, let's go ahead and we can disable this, and let's, for the sake of something different, let's go ahead and do the web keys, just in case you encounter some idiot still using the web. We can apply that. Save that off to 3. And we can run that real quick, and we can see it's where it showed up at the top of the screen. So we can see that these devices also give up their web keys. So by doing this comparative, and you can see how simple it is, with a simple diff, with SNMP walk, SNMP bulk walk, or SNMP get for various values, we can go back and forth. You can quickly discover devices that have been key pieces of data where it's stored in the device. And this is a good method, especially if you're dealing with data that may be encoded or encrypted. It may be not obvious just looking through the device, but this makes a method for actually being able to do that. Does anyone have any questions kind of at this point? Does everyone understand what we're talking about? And we've actually proven that there's a lot of dumb shit out there. Yeah, I've yet to figure that one out. You know, typically we expect benign data in the within the SNMP MIB tables. We want benign data. It's data that we can use for management. We can check temperatures. You know, hey, you know, is it configured right? Things like that. But unfortunately, as you see in this so far, they're actually exposing things that we would actually consider things you don't want exposed. But then we're dealing with other things. Not only is the vendor doing this, but as we've shown, we've already showed you a half million devices we've already told you are on the internet. And trust me, there's a lot more, where you can pull the WPA pre-shared keys, the web keys, remotely over the internet. What about the ISPs? Damn, you know, that's pretty bad.
But a vendor went through some trouble to actually store this data in the public community.
Yes, he did. And no, they have not given me an answer. And yes, I've asked. And their answer was, well, the devices that you showed us are end of life, so we really don't care. And we're like, have you bothered? I actually asked one of them, I said, have you actually, because I actually had Ubi on the phone. And I said, yeah, but you know, you bring MIB tables forward, or are they still in your current devices and in silence on the phone? Okay. And I goes, well, what are your most current supported devices that I can actually get my hands on? And then they clammed up. They wouldn't even tell me where I can get my hands on a device. And then they vaguely accused me of extortion. And I'm like, extortion what? Like, this is like extortion. I'm like, well, we don't want nothing from you. We're trying to help you. Okay? So it was kind of interesting. Let's kind of move on and get through the rest of these slides. So here, from the demo stuff, here is the WPA. Here are the information that we actually showed in the demo. So actually in the slide there. So moving from here, getting into automated information gathering. I'll end automated information gathering. I think a lot of you have seen me speak before. So what can we do actually with this easy to do so you don't have to think about it? That's always cool. So and hopefully every day you're trying my tool. Gosh, okay, we got one person. Pwnd was released a number of years ago. It was originally written to pull data via multifunction printers, and it's like a totally badass tool. Okay, at least I think so. So it's Pwnd is Latin for plunder, booty, spoils of war, and that's what it is. We're stealing data, and that's what its purpose is. Currently, it pulls a bunch of stuff. You can download it from right there. All of the stuff we showed you today is not out there yet. It will be before the weekend's over with, so you can pull the new version down, and it'll be able to attack those specific Netopias. You'll eventually get yours over there. Netopia, Ubi devices and stuff like that. Next slide. So moving from there, we all know I work for Rapid7, right? Everyone know I work for Rapid7? Okay, cool. I work for Rapid7. So we got a new project going on called Pwnd. Cool name. And the goal is we're migrating Pwnd over to Metasploit, all of the modules over to Metasploit. We've started that. Pwnd is not going to go away completely. It's still going to be written as a scan search engine that can fingerprint embedded devices that contain data that you want to steal. And it'll be nice enough to pass that over to Metasploit to steal it for you. So that's ongoing. We don't know where that's going to be right now. So move on to the next slide.
The SBG 6580 will be available at the bottom URL there under my fork of the Metasploit framework later this weekend.
Oh, you actually put that in there? Apparently I was drunk or passed out when you did that. So we actually have a couple demos here, a Metasploit and a Pwnd demo that we're going to do. So Matthew's going to jump over there and do that.
All right, I'm going to demonstrate.
Just go down the bottom screen and pick that up.
I'm going to do a quick demo of the SBG 6580 module I wrote for Metasploit. All right, so first thing we're going to do is we're going to load the module up. It's under the auxiliary scanners SNMP directory. We're going to check the information there, and we'll see that we need to configure it with our hosts. So we'll set our hosts to the IP address of the SBG 6580 on our LAN. Confirm that it's been configured and running. And like that, you get a lot of information about this device, nicely formatted, without all the work of digging through the OID dumps. This will also enumerate more like web keys, all of the wireless encryption configurations on this device, including radius. It'll give you back the radius server and key. And I'm going to turn it over to Daryl.
Yeah, you don't need to go to the next slide.
Daryl's going to demonstrate Pwnd for us.
Okay, so that's like totally cool. Okay, don't you agree? So now you can eventually impress all your friends how you can steal their WPA key off their devices, especially if they're using an ISP that's published their public SNMP to the internet. Wouldn't that even be cooler? So, so with the Netopia, in this particular one, the SBG 6580 module is not in, but it's available. You can you'll be able to download it, right?
It'll be available on Enoki's port or fork of the Metasploit framework on GitHub,
which will eventually be incorporated in. Modules for the Ubi, Ambit, and the Netopia are in the current download version of Metasploit. So if you download those, it'll pull that in.
Yeah, I'll be looking to land that hopefully in the actual Metasploit framework's GitHub. For now, it'll be available under mine.
So now we get to demo the ultimate uber cool tool, Pwnd. And hopefully it actually works. Okay. So how many pen testers we have in here? So we got one. Have you ever used Pwnd? Have you used it? Cool. Okay. I would recommend giving it a try. We use this during all of our pen tests, and Pwnd is capable and successfully pulls Active Directory credentials off a number of multi-function printer devices, probably on upwards of 50% of the engagements I'm on. So we look at this real quick. We can see there's a simple command structure. You can either pass a nmap, gnmap output file right into it for scanning. You can pass a target file, or you can pass a CIDR into it. In this case here, we are actually going to pass a CIDR. We recommend we put a port number in. We fingerprint using a couple different things. Almost all embedded devices have web services enabled, so that's easy enough to use that information typically to fingerprint it. We create a project name. We'll call it CC10. And then give it a log, and we'll call it test 1 in this example. And then when we run it, and hopefully it works. I hope I hit enter. Did I hit? Oh, there, yeah, enter. Yeah, our number one device decided not to work for some reason, so I think it's the Ambit, or I grabbed the wrong one in a drunk stupor this morning. So it goes through it. What it does is it fingerprints the device, and then it calls it's all Perl based. It calls a module that it finds. Once it fingerprints it, it knows what module to call, and it carries out these various attacks, and it enumerates data off the devices here. So let's go ahead and stop it at that point, and then we can change over to the CC10 folder that it created, and we can see it created a number of files. The one we're interested in here is the test1.log. And as we quickly see, it fingerprints the device. It gives you information about it. The device is configured WPA, pulls the WPA keys. This one gives a username and password, tells you what the SSID is. It also says WEP's enabled. It pulls the WEP keys. It also tells you what's the active WEP key that's being utilized right now. And then also the Motorola device, the same thing. It actually gives you pre-share key information or WEP key information on the device, ever how it's actually configured. So it's a nice little tool. You can typically, during assessments, you can just kick it off and let it run. And it will, if it detects any devices. And these consumer-grade modems and DSLs we're talking about, you think, well, where would that come into play on a... These are home-based systems. Yeah, they are home-based systems, typically. But I often find a number of these devices deployed in small business, or in small businesses and large business satellite offices. So you do still encounter these things. So that's why we build it into these pen test tools, because even though some of these are end of life, they're going to be around for another 4 or 5 years at least, and we do find these in businesses and corporations on a number of occasions.
Or as I wanted to call it, enterprise surprise.
Enterprise surprise, there you go.
Now we just demonstrated a lot of, consumer grade hardware, and that's just because it was affordable for us to start a research there. But I don't want you to leave here thinking that it's only devices like this that are vulnerable to information exposure via SNMP. Deral found a good example during one of his pen tests. He's going to share it with you.
Next slide. So during a pen test, an external pen test, I discovered a company that had deployed a Brocade load balancer. Very popular load balancer. I think it costs around $20,000. So I can't demo one today. No one's nice enough to give me a $20,000 device to screw with. That's why I'm a pen tester. I'm paid to screw with their devices when they don't expect it. So it turns out, looking at the Brocade, there's actually upwards of 9,000 of these exposing SNMP to the internet. These are enterprise-level devices in large corporations. During my pen test, we discovered SNMP exposed to the internet. I pulled, using SNMP walk, the entire tree structure of the device, and I took the time to look through it. Turns out what I found was I could pull the username and the password hashes all configured on that device for the administrators. So pretty big. So it is a password hash, so you have to crack it offline. But if people have not realized, there's these things called GPUs. You can speed this process up fairly quickly, especially if it's not a very long or extremely complex password. And in this case here, I was able to crack the password on our device in less than 24 hours, which eventually gave me full administrative access into their load balancer over the internet. Like I said, there's 9,000 of these exposed out there. Go to the next slide. So we do have a Metasploit module that's deployed out there, it went out yesterday, that is available to do that also. So in this example here, so this is kind of funny. So this example here was a snapshot of a real assessment chunk, okay? But this has been cooked. So all you people are taking pictures of this and try to crack these passwords. If you crack one of these, let me know, because it's totally fabricated. Obviously, I don't want to put something out there that's real world reality, but this is the real scan. The only thing I did was switch a lot of things around so that they're kind of cooked numbers. so that I wouldn't compromise, a customer or something like that. And the names have been altered a little bit. But the tool's kind of cool. If you can pull this data down, the key thing I want you to think about on the whole thing is, so I can get access to the Brocade load balancer. If I crack these passwords, what else do I get access to? More than likely, I'm going to get access to all of their network infrastructure, their switches, their routers, their firewalls. Because these are typically going to be the network administrators that have put these devices out there, at least some of those accounts will be. So you can see the critical nature of this vulnerability. And I've had people come to me and go, well, it's S&P public, and you should turn it off. Yes, but what did I say earlier? We got 17,000 people or 17 million people, 17 million instances that have not turned it off, that exposed it to the internet around the world. I go into companies and organizations, and you can ask the pen tester back here too, how often do you find devices with S&P public community string enabled? And I have to admit, I can count on one hand the number of companies that I've found that do not have occurrences of that on their network. I find it every case. And it's very critical. It's very concerning to me as a pen tester. And that's where this whole project started from. So it's kind of cool, and I'm hoping you guys enjoy it. Next slide.
All right, so what can we do to mitigate risk? Well, let's start with the vendors. Vendors should stop placing sensitive data in public community that's enabled by default.
How many people agree with that? Okay, we got a consensus.
And we should probably move away from version 1 and 2C as community in favor of a stronger security model. Deral, what should end users do to mitigate their risks?
Let's turn it off. You as technologists, when you go back to your company, the things that I want you to consider doing in your organization is you're going to build processes and policies that control the deployment of new technologies in your company. So as part of that deployment process, you need to create a process that says, before any device goes out, we have a checkbox. Is S&P enabled? Do we use it? No. Turn it off. Do we use it? Yes. Set it to a complex community string. But not only set it to a complex security string, set different security levels. I've lost count of the number of routers, switches, and firewalls, Cisco, that I've compromised in an organization because I was able to strip the S&P community string that they were using off a camera on the network. Okay? Those are different security level devices. Do not use the same password. Okay? It's no different. You do not give everyone in your company the same password that you set on a domain admin account, do you? So don't do that with your devices either. Also, do not expose to the internet. So if you follow the first two rules, you're probably not going to expose it to the internet because it's going to be turned off. But also, think about devices that you deploy to the internet. Somewhere, 9,000 people decided, hey, we're putting up a Brocade load balancer, and we need people to get access to our web servers or our applications that we're load balancing. So what should we put in the rule of the firewall? How about any to that device? That way we won't have any problems. Bullshit. Think about what you're doing. Do not do those things. Actually configure your firewalls to block everything but what's needed. And that'll help resolve some of these issues also. So that is our presentation. I hope you enjoyed it. You had some fun out of it. Is there any questions? Yes, sir. Some devices do log these requests. And it's interesting dealing with logging on these devices. I found a number of devices that log everything on S&P. So it is also possible, I haven't found it yet, but I'm looking, where someone could log onto a device and inadvertently enter their password in the username slot and actually have it logged into the log system. Because I found them logging the usernames of people, but not the passwords on the devices. So the whole logging, and I don't think it's on every occurrence. I haven't validated that, but I do believe some devices appear to log those type of transactions. Yes, sir.
Have you done any research on actually the SNP agents running on the device itself, like
Actually, this is the entry point for a larger project, okay, that me and Matthew are working on. So expect some, that's one of the reasons why I got myself an IANA assigned number. So we can actually, the goal is to actually create, hell, you know, if you want to steal the whole thing from me, who gives a shit? The goal is to actually be able to create a device, a small device with its own mid tables, so that it can be used to attack management control agents. That's the goal. In the okay. And like to look into that any further. So
I think a lot of those would be like the web interfaces on some modems where you see the log, but it's like the last 100 entries or something.
Yeah.
Which brand of cable modem vendors do you have the best vulnerability notices like? So if, say, the cable company, like the cable modem and whatnot, which one would you recommend?
yeah. You know, I'll tell you straight up, who cares? Buy any cable modem you want. Who cares what they do? Just don't use their wireless services off that cable modem. You'll be fine.
Well, beyond that, I mean, check your ISP. I know some ISPs are shutting it down. In fact.
Yeah, a lot of the new stuff is being shut down. And by default, SNMP is not going to be enabled on the uplink of these devices. The vendor or the ISP has to enable it on the uplink. So by default, these devices are not going to enable that. By default, half the devices we talked about, SNMP is enabled on the downlink, the inside side with this data, so, but not the uplink side. So we're actually seeing a lot of the vendors, at least the current stuff, seem to either be disabling it or setting it very complex community string that they control. But we're dealing with a lot of legacy, a lot of its legacy issues. Bell South, AT&T, literally, I think I had over 100,000 in the U.S. Netopias that are allowing SNMP over the internet, and those are generally Bell South. So everyone here in Raleigh, if you happen to have a Netopia, I can probably pretty much guarantee you if you're using the wireless, so is everybody else. I think that pretty much finishes. We're out of time. We're going to be around today and part of tomorrow. So feel free to grab us if you have any more questions or you want to talk. Thank you very much.